Welcome to Rubber Duck Engineering, a show where we talk about code and stuff once a week. Hi, Adam.
Hey, Eric, what are we talking about today?
Tonight we're talking about Flutter.
Flutter. Well, before Flutter.
Before Flutter, how we got to Flutter.
The story ends with Flutter, but it begins somewhere else.
Well, it's episode 100. Happy 100.
100 episodes.
100.
Amazing.
And so Adam and I were scheming for what we should do for episode 100. And I know we were doing ML stuff last week, and we'll get back to the ML stuff because ML's fun. But we were thinking that we should look at Flutter because I don't think we've done this publicly.
I don't think I've done it ever. Like I learned a lot by going through all the commits and seeing what did we actually do? How did we get from point A to point B? Like my memory of it was a lot fuzzier than turns out. Git just remembers everything bit for bit, word for word.
So Flutter was entirely done in the open the whole time. And so Adam and I last night just spent a few hours looking back at the Flutter repository from the dawn of time and the Flutter engine repository from the dawn of time. And it was just fascinating to see how, and to remember that part of our lives. But it was a wandering road.
Yeah, we sort of got there in like a totally backwards way. We did not at all set out. Like normally I think you start a project, like maybe you start with a blank piece of paper and you start adding code to it. That's not at all how Flutter started. We started out with a code base with millions and millions and millions of lines of code, and we took a machete to it and just totally destroyed it.
More than a machete or two, but yes. Well, you used to tell, maybe I'm ruining, maybe this is for later in the show, but I remember you used to tell the story of we were trying to go to grandma's house, but we had an aircraft carrier.
Yeah, this is like what it sort of felt to try to make the web work well on mobile. Like the web was this aircraft carrier that had a dentist office in it. It had like a kitchen. It had like a nuclear reactor. Had everything you could possibly imagine. And on mobile, we were trying to do very simple things. Like we're trying to the analogy was go to grandma's house.
Yeah.
And sort of the inciting idea behind what eventually became Flutter was, what if we just stripped down this aircraft carrier into a truck, but we kept the nuclear reactor.
Yeah. And the gold-plated diamond-studded nuclear reactor.
The gold-plated diamond-studded nuclear reactor, and use that as the engine for your truck. Wouldn't that be an amazing way to get to grandma's house? It made no sense. You have to be crazy to start a project like this. If you think you're in your sane mind and you start something like this, you're just mistaken. You're just not at all sane.
I don't actually know of another project. And there's just so much weirdness, and we'll get into this as we sort of go through the hit, because we made slides tonight. I don't know if we'll actually go through all the slides, but we made slides, which I don't think we've ever done
for an episode
for RDE. But it's such a weird way to start a project. I'm not aware of what ever started. Hey, welcome. Because it's super inefficient. Like we had 6 people, tearing this thing apart for 6 months before. Like we in the end deleted every last bit of Chrome, and we could have just started from fresh, but like I also think that the project learned so much from that.
Yeah, there was an emotional journey. There was a technical journey. Like it was a journey. Should we start the slide deck? Like you made a slide deck. We should use it.
We did. We made a slide deck. Let me find the buttons. The buttons of destiny. That's the button.
Sure.
Yeah. I don't know how to make it like prettier. I don't know, but whatever. It's good enough. So, this is a story in 3 acts.
Act 1, inspiration.
So, I think that the context, so we're back in 2013 for this, and I think important context to set the entire story is that we're starting the story right after we forked WebKit. And Adam and I were deeply involved in that. Like, we made it happen.
So, just to understand, in case people aren't familiar. So, Google made this browser, Chrome, but it shared the rendering engine for Chrome with Safari. It was an open source project called WebKit. And for many, many years, we worked together. Eric and I worked at Google. Many other people worked at Apple. We collaborated on this open source project. Yep. And then at some point, we went our separate ways. We took a separate copy of that code base, renamed it to Blink, and then we took it forward in a direction to try to make Chrome as good as we could make it.
Well, and so much of our jobs changed as a part of this. So like I had actually worked on Safari at Apple before. And so like my job for many first years of the Chrome team was like, helping others learn how to contribute to WebKit, helping us get changes into WebKit that were like politically difficult, or like, we had to talk to the right people there. And so like there was so much of like our jobs was like learning how to operate with another company, right? Who had totally different incentives, and like, but we had to share a code base.
Competing interests. Like I remember a very visceral memory of I met with the head of the WebKit project in like a coffee bar in San Francisco or something, and there was some like disagreement going on, as there always was. And that month, The Economist had on its cover these like 4 giant like squids that were like intertwined and wrestling with each other, and one of them was labeled Google, and one of them was labeled Apple, one of them was labeled Amazon. I think the last one was Microsoft or something. And I just like showed this to the head of the WebKit project, like, this is our life. Like, here we are on the cover of The Economist. Like, it's like a microcosm of that. But anyway, the fork let us put all that behind us, and then we became responsible now for the quality of the web engine inside of Chrome.
Which is just such a different, like, suddenly your job shifts from being an evangelist, and like the back pressure on the system came from external to now you are the back pressure on the system. And I remember us thinking a ton about that, about how we were going to like make sure that to help Google preserve and not like break the web, because that was a concern. And anyways, the whole game changed. So like we fork. That's where we are. And then there were like other things going on, like I think we were starting to wake up to the idea of mobile. We were a little late, but like we were waking up to the importance of mobile, and we were experimenting. And you were more involved in this one than I was, but you want to talk about Bravo?
Yeah, so Bravo was sort of an experiment. So the idea was sort of similar to the idea of what eventually became Flutter is, what if you stripped away all of the web platform and stripped it down to just its essential pieces? And so in this view, the essential piece was you had some universal app like a browser, and it would fetch just JavaScript over the internet from some URL. And you run JavaScript and you run it just against OpenGL. And maybe you had some networking APIs or some APIs to make the phone vibrate or something. But then on top of this like JavaScript GL foundation, you could then self-host a framework and build back the web essentially with the DOM and nodes and elements, and build it all back up in JavaScript. And then already we had the idea here that maybe you wouldn't build it up exactly the same way that the web was built. So like we had the idea that maybe you didn't want an HTML parser in this framework. Maybe you would deliver the serialized version in JSON, because that felt more JavaScripty, right? And then like in one of the difficulties in making the web work well on mobile is a very important aspect of the engine is a thing called the layer tree, which is how graphical compositing works. And we also had the idea that maybe you should be able to access the layer tree. Since you're responsible for talking to GL, maybe you could then be doing the compositing yourself. And even at this point, we had a visceral hatred for float layout. So the design doc was very clear that we should think about what kind of layout models made sense, but definitely not float. Float was not coming to Bravo.
It's amazing how much of this like was repeated in the 3 more attempts of this we made, the fourth of which ended up being Flutter. And also some of this, how much of it was a product of the time. So like layers, for example, that came forward into Flutter, explicit layer management. But it also was like a particular pain point at the time because we were dealing with layer explosions. Like where, one of the things that was happening we saw with customers, and I think the next slide talks about customers, like you would talk to Gmail or you would talk to, any of these other customers, is they would like add one little thing, and then their carefully crafted perfect app that had worked great yesterday now suddenly worked terribly for reasons they didn't understand. And layer explosions were one of those reasons.
It was all implicit, right? You would set these few magical CSS properties, and it would drastically change how the browser would like draw your page.
Yeah.
I think on the next slide, you have to make, so can you click through a couple of those examples? So just to give you an example, like what did a Bravo app look like? So like, these are all public. These URLs all click through.
Yeah.
So this is an experimental Chromium repository.
Yeah, everything we're talking about is entirely public on the internet today.
Yeah, so this thing just drops you into main in some JavaScript function, and there you are calling GL clear, swapping buffers. Like that's all it was.
Yep.
And the like key metric for me for this was when you tap the icon on your phone, this thing could fetch this JavaScript file from a web server, load it, execute, and clear the screen to green before the animation to load in your app had actually finished. And these examples get pretty complicated. So this is
you had your own URL loader here, and
yeah.
I don't know which one you wanted me to show.
I'll show box and triangles. I think is a good one, just to give you a sense of like how complicated these things got. So this is some code that we got from somewhere else, but then because it was JavaScript and like GLE, we could like plop it into this environment, and it could actually do something non-trivial pretty easily. You don't have to like, you just scroll through it just to give a sense for how many thousands of lines of JavaScript code it would take to do anything non-trivial in this kind of environment.
It's interesting to me. Like we had this tension that you'll see later in the deck that we resolved with Flutter of between this, like how much is in C++ and how much is in userland. And it's interesting, this was still straddling that world where like a bunch is down in C++, but then you still had to write a ton in userland.
Yeah, this is deeper, right? So like in Flutter, what you get is a Canvas API where you draw much more abstract things like circles and, text and stuff. Here, you're like literally, no, load up your texture. Okay, here are your triangles. Go. There's not even a tesslator. You have to write your own tesslator, which I think was not as good. So like, especially the way the industry turned out, where GL has kind of gotten replaced, right? With
Vulkan and metal and stuff came.
Like if we'd actually shipped this thing, like it would feel really dated now because it wouldn't have been able to come to the like metal Vulkan future. Yeah. But even here, we had an idea of a DOM-like framework. Here I wrote it in CoffeeScript because I don't know. It was a horrible idea.
Anyways, we should keep going. We were also, so that was sort of your side of the world. You and I were working closely, but not always. One of the things that I think was novel for me in this time is that, and that changed as a part of the forking, was we started talking more to customers. Again, historically, I think, I don't know whether this was just an excuse that I told myself, or maybe this was like part of the team, is that we sort of tried. Chrome was separate from the apps inside Google, and intentionally so. Like we didn't want to build a browser just for Google. We wanted to build a browser for the world. But like I think that also excused us from actually talking to customers and like understanding their pain. And I recall in this time really talking to Inbox and talking to Search, and just learning so much about their pain. Like I remember we worked with Inbox and just tried to have a 60 fps animation, and it was just unending pain of. Like I remember we found through this that it was impossible, not possible at all, to parse like a single character of HTML. No way, no API possible without janking. And just like that sort of baseline stuff. And as we alluded to before, you had like one CSS property and your whole thing falls down.
And to be clear, we spent many years improving the situation. Like this is not the situation today. The situation on the web today is vastly better than this.
I mean, this was 9 years ago.
Yeah, in part because of some work that we did and a lot of work that a lot of other people did.
When it's inspired so much. So like, again, with that, like there was a lot of work at this time to just get off the main thread. Let the main JavaScript thread be the apps thread, which we did in Flutter. But like some of that was like the Chrome grew a scheduler in order to do that. So, okay, that was sort of setting the scene, Act 1. There's probably more we could talk about there, but let's talk a little bit about how we got the failed attempts that we got through to get to Flutter, because there were many.
It was basically just like failing repeatedly until we started failing less. So this is the first failure, failure 1.
Well, this is, I think, this was another fork in the road, where you and I ended up leaving the Chrome team effectively, or sort of, moving organizationally, along with some other people after the success of this experiment. This was like a couple weeks where we took a machete, not literal, but a digital machete to Chrome and carved it down a lot and really moved the benchmarks, or benchmarks that seemed useful to move.
Yeah, so we were just deleting thousands of lines of code like constantly for a week. And we were like, okay, how fast can we make HTML parsing? So we had a theory, like you saw in the episode we did on HTML parsing, the tree builder, like how many complicated like branches and things are going on in this tree builder to like build a DOM. And so we're like, okay, what if there was a thing that wasn't compatible with the web, so didn't know the quirks of all the different elements, and just treated every element the same? And document.write, which is this crazy way of re-entering the parser that we didn't even implement in that episode, which really massively complicates the parser. What if that didn't exist? How fast could parsing be? And we got parsing to be 19 times faster. Not 19% faster, not 10 times faster, but almost 20 times faster.
And this is, of course, a couple years after you and I had rewritten the entire parsing system to make it faster.
This is a brand new parser that we had tuned as basically as well as we knew how. And in 1 week, we could make it almost 20 times faster by shedding the complexity of being able to be compatible with the web.
And to be clear, the resulting, sorry, I didn't mean to talk over you, but the resulting examples, maybe we'll get to some of these, didn't look that different from the web.
Yeah, basically, if you have like normally well-formed JavaScript that doesn't have crazy reparenting, or you put in a few self-closing tags or whatever, like it basically parses web pages mostly. So like the benchmark was we just ran the HTML spec is this giant pile of HTML, which we were using as the parsing benchmark to build the parser originally. So we just parsed the HTML spec, and it mostly parsed, like it mostly worked right.
I remember that we used the HTML5 multi-page as
the single page. The single page, which is a huge handwritten page. Anyway, similar win. We don't have to go through it all in detail, but similar wins in style recalculation. So in style recalculation in CSS, you can write selectors that involve traversing the tree to figure out whether your selector matches, which is massively expensive. If you do this naively, it's n squared, right? Yeah. Find me a node, check all of its descendants to see if they're like this. Okay, now make it blue, right? And so there's a huge complexity inside a web engine to make that efficient. So there's literally a Bloom filter in your CSS selector matcher to try to quickly reject things that aren't going to work, so they don't spend a lot of time trying candidates of things. So we said, okay, what if we just got rid of all these tree traversing selectors, stuck with simple selectors? You have to write a little bit more verbose CSS, but maybe you could be faster, right? And so we got it to be about 4 times faster. So not as huge a win as parsing, but still a lot faster.
What's interesting to me, and this is why it references back to the earlier part, so much of this stuff that you see grown, like the Bloom filter and stuff, happened as a result of the earlier years of like just trying to make it faster. And like when you talk about the adding a descendant selector, teams inside Google, and I'm sure teams in other parts of the world, have linters basically on their CSS to ban certain selectors to prevent this kind of, oh, the intern added a whatever selector, and just now magically my entire app is 20 times slower.
So this thing got us really excited. So we did this thing, we wrote this paper, and we showed it to our boss, and we're like, okay, boss, look at the potential here. Like, give us some seed money. Let us try this in a non-hack and slash way and see if we can come up with a sort of slimmed down. The idea behind Razor was we were shaving off all the yak hair, like the slimmed down version of the web that like maybe could be good for something. And our management chain was very gracious, and they allowed us to do this.
Yeah. So shortly after that, we started what would become Flutter, and at that point was called Sky. So Razor was again the hack and slash thing. Sky was, I think we also called this briefly low-level HTML or something like that. Like it was an attempt to make a fast version of the web. Like
the Razor thing, we just threw away that prototype code. That code was not in any shape for anything. We just started again, like took a new fork of Chrome and then started deleting things again.
Yeah, and I think we actually still had .html, or we had .html briefly, or
I think we renamed HTML to Sky just to not get confused. So can you follow some of these links? Can we look at like the spinning square? Like so the very first thing we needed a demo app. So the demo app was a spinning square. And so here it is. Like it looks like HTML, right? You like instead of an HTML tag for the whole thing, you have a Sky tag. But what difference does that make? But it's got a scow block with selectors, and like it's got some tags and some script tags, and it's got request animation frame and spins the square. Just like you could feed this to a browser, and I think it would work. Like
I actually think this exact code would probably render just fine in a browser. And if you look at the commit history, which you can do, again, it's all public on GitHub. You will just see us every day for 6 months just deleting stuff. And I didn't highlight all those links, but just deleting and deleting and deleting and deleting.
It felt like peeling an onion. And like we were talking about with the nuclear reactor, yeah, the glorious spinning square. Like I've been doing projects for my entire career revolving around spinning squares. I thought, or that what I felt at this time is that when we peeled this onion, eventually at the bottom, we would find this golden nugget, the nuclear reactor in the aircraft carrier analogy. Mm-hmm. But what ended up happening is we peeled it all the way to nothing. And turns out there was no magic inside of the code. The code is just code.
Yeah. And it's not to say that the web isn't amazing. Like, again, big fan of, but it just, we had thought there was some like kernel, and we ended up, again, just discarding all the layers of the onion, which we'll get to. So also at this time, we were both trying to like peel back the past. We were also trying to push forward into the future. And so we were turning on every bell and whistle we could inside V8, moving to the future of JavaScript.
So this time was called ECMAScript 6. So like classes and things like that. That was all the future. That hadn't happened yet. But it was all being partially implemented inside of the JavaScript engine to track the spec and such. And we just turned all those things on. We're like, that sounds great. Give us all the cake. We'll eat it now.
Basically, anything we saw come out of the V8 team, we turned on as soon as we could, which was great.
We turned strict mode on for everything. It was good times.
So I guess not too long after we started a framework, just similar to what we'd done, what had been done before. And there was actually some other things we didn't talk about here. Like I remember some other motivating examples. We had tried to build some basically copies of Android mobile apps on the web and mobile. Like we tried to build a copy of the calendar. We tried to build a copy of, I think the calculator, but I don't recall all of them. But like, and in getting to that and building towards that again, we built a framework. You were saying, sorry.
Yeah, we wanted to compare like apples to apples, right? It's one thing to say, oh, can you take the New York Times desktop homepage and render it on a phone? It's a different thing that like, can you do the same thing that the built-in calculator does, right? If you can't do what the calculator does, then something's got to give, right? So
it's also a lot like,
yeah, okay.
I was just saying it was a standard. I didn't think that, again, and I think in our isolated desktop-focused worlds, or at least I can't speak for you, or certainly not the web platform. I felt like we had maybe ignored these. It's like it was okay that we hadn't proven that we hadn't proven that we could perfectly match the Android calculator. Because like, of course we could. Like we're the web. But like when we tried and we couldn't, I think that was very instructive to me.
And it became like an anchor point for the whole effort. Was like, okay, these are the user experiences we want to create. Let's make sure we can create them accurately. So if you're familiar with web components or Polymer, you'll see that this is very similar to that. So you have basically a custom element that contains a template for the HTML, and there's a like associated style and associated scripting. And it was because we knew a lot about Polymer because we had worked with them closely to optimize their code, and also we had some folks who had worked on Polymer come and work with us, and so they brought their influence from that.
And you'll see and this is again started the ethos that we started to have as we were tearing down the C++ and we were building up the JavaScript side. Sort of there was another thing that was floating around. You can find it on GitHub, the Extensible Web Manifesto. Someone wrote it.
I still reference, by the way. I still talk to people about that to like as like a good way of structuring a platform. Some really good ideas in there.
It was basically a letter to the W3C and others of stop giving us random super deep APIs to do whatever, Bluetooth, whatever, and start explaining out the platform. Like there's aspects, the web API is incredibly uneven. Of like you can have like super basic things like Canvas, and you also can have super like high level things like an undo stack. Or undo stack is maybe a bad example, but like a paste command or.
Yeah, so this particular example, we were trying to re-implement XML HTTP request on top of a lower level networking primitive. And part of what we were trying to experiment here is like, could we hide some of the implementation details? Because one of the things about JavaScript is it tends to spill its guts. Like it's hard to make something private in JavaScript, or at least at this time. And so you can see we used a thing called a symbol, which I don't know if it ever actually made it into JavaScript, but was in one of the earlier ECMAScript 6 drafts, which was like a private way of associating a hidden object with your public object.
Yeah.
I don't know if it really worked out, but it was a thing we were trying and seeing what it did.
It reminds me, I don't think we put this in the deck, but I know I implemented the Web Inspector protocol in JavaScript. So that the Chrome Web Inspector could talk to Sky, like the Sky Inspector. And so we could use the Chrome Web Inspector or parts of it to inspect Sky.
By the way, this has been done for many platforms, actually. So you can actually use the Web Inspector to inspect things built in totally other UI frameworks, because the Web Inspector is such a great tool that people want to connect it up to anything. So it was a very useful thing that we had at the time.
Well, there were a bunch of things that I couldn't implement because they required the Web Inspector needs your protocol really to be on a separate thread. from the thing that you're inspecting. And so like, because it would call into you and it's sort of a debugger or whatever, it like want to interrupt to be like, hey, give me all your CSS and layout information. We're like, well, I'm busy, I'm paused or.
So this example is the input element, right? And so just to show you how much we were still leaning on the engine. So the input requires text editing. And so in the web, oh, thank you, Giffy. I'm glad you like the show. So in the web, the way we could do this, the most primitive form of this, you could put an attribute on your element called content editable, which will turn any div you like into a full rich text editor.
Oh, it's incredible.
So that's what we did here to make the input box, is we put content editable on a div and be like, okay, here's your editing control. But if you scroll down to the key down handler, there's a fascinating comment here. So I wanted a single line input control because that's the way like an input element works, like on the web, right? And so when you hit return, I said prevent default, don't actually add a new line to my thing. But it turns out that doesn't actually make it a single line input control because the user can paste in something that contains a new line. And already you're sort of seeing that when you're still at this level, even though we stripped down the engine still had a bunch of implicit behavior that you couldn't control as the developer, which means you couldn't actually create the user experience that you wanted to create. And so in building all these things, this is what we were feeling. Like we weren't just like spamming out all this stuff. We were building this thing to see like, is this good? Like, is this going to let us build the thing that we want to build? And these little signals like this are very powerful, and you have to pay attention to them because they're like signposts. Like if you can't get the input control to do what you want, you're not going to get a super complicated, rich interactive app to do what you want.
Mm-hmm. Yeah. Should probably keep going. So this is we're 5 months in? No, not even 4 months in or something from when we initially sort of gone off on this quest. We were built up alongside another team that died and then was reborn into several other teams. Thanks. Called Mojo. And so you'll see Mojo referenced in some of this, and you can find some old Mojo code on GitHub. But this was a fork for us, is that we moved away from using this Mojo environment to starting a direct embedding in Android.
Correct. And so what this allowed us to do is basically focus on mobile. So Mojo and Chromium are these cross-platform toolkits that they run on Windows, they run on Mac, they run on desktop. But SkyShell only existed on Android at the time. And so, oh, thanks, Jax. Yeah, so this basically said we were going to focus on Android. So here we still had the idea of this universal app, remember from Bravo? So SkyShell was the everything app. It was like a browser in that sense, where you would feed it a URL, it would go fetch your application from that URL, and it would become that application.
Yep, it was basically a browser. It just, you would ship this magic browser, and this is a decision that we ended up having to unwind, which is actually a thing I don't know that we cover in these slides, but I feel like sometimes when I talk with people and they're like, "Oh, wow, you all were so genius and insightful and whatever," and I one of the things I hope we talk about on this show is that no, the important thing is so much just starting and failing, and like you become an expert by just failing enough times.
Right. Each of these things is a course correction, right? The reason we created SkyShell is because our previous embedding environment was broken. It was wrong. We started in the wrong place. And so this was a course correction to say, no, we need to focus on mobile. We need to shed a lot of the complexity that came with this starting point. We'll create a new shell in which to do a thing. And we still had a ton of wrong ideas. Like this idea of fetching your app over the internet every time you launch the app doesn't work, right? But we're still there. We're still making all these mistakes. We're just like feeling what's going on and trying to respond to it and iterate on it.
SkyShell was still a base Chromium application. Like, wow. Of course, we still sat on Blink at this point. I hadn't realized this was basically still running Chrome effectively. SkyShell was just a really stripped Chrome.
Correct. We no longer linked against the desktop part of Chrome. We had linked only against the Android part of Chrome.
Wow.
we're not going to get anywhere near impeller. Like
Yeah.
the story is going to end where Flutter starts. So sometime later we'll have to talk about that, what actually happened with Flutter. We're still in Skyland at the moment.
But anyone should feel free to tweet at me. I'm happy to talk impeller. So we did a bunch of stumbling. This is now we should talk about like how Flutter started to come to be and we started to find it.
So this is a huge moment in the project. So up to this point, we've done everything with JavaScript. And as you can see, we were iterating really quickly, right? We were like 10 times a day. We were just moving thousands and thousands of lines of code around, ripping things apart, deciding we hated things, turning things on their head. But we still had JavaScript. And JavaScript was a dependency that we were not writing the code for the JavaScript engine. We were still using the JavaScript engine that was used in production in Chrome. And so that JavaScript was still tied to the web ecosystem, whereas the rest of our code was free to change and break and be totally weird and different. And so we worked very closely with the team and we had lots of really good conversations, but they never did anything for us. So like this is an example of a bug that I filed. I said, hey, normally on the web, when you have a script tag, if you make a variable there, that's a global variable. And some other script tag somewhere else in your project will then collide under these global variables. So we thought, oh, that's not a good idea. We said, what if every script tag had its own scope, right? And so then you can have variables that were scoped to that script tag that wouldn't collide with other script tags. But there was no API in V8 for saying, okay, parse this chunk of code in its own scope, because that just wasn't a thing that it did. So instead, we had to like wrap it in a function, new function declaration, which meant if you put a curly brace at the end of your script tag, you would get a weird error because it would complete like the syntactic wrapper we had given was not, it was leaking its implementation. And so I filed this bug and say, hey, can you just give us like a text to code object that does this same thing as if we had wrapped it in a function block so we can avoid this hacky thing that we're doing.
And to be clear, this is not a knock against the V8 team or anything. Like they were doing the right thing. They're taking care of their billions of users.
We were no one. Like we had 0 users. Like they should give exactly 0 like F's about us, right? Like.
But like the new line thing, like where we couldn't get rid of the new line, during paste or that fix me, it's that same thing. Like we were just learning that like what we were trying to do was incompatible with the like underlying pieces we were building from. And this is one of, tens of examples we could find of where we chafed against the edge of JavaScript, or we chafed against the edge of the incentives for the teams that were maintaining JavaScript. Again, because they had billions of users to think about.
And to be clear, in some projects, it's totally fine to have things that chafe, right? And then just to plow through them and make a thing that works, right? But part of what we're doing here is we're trying to build this future. And so each of these like paper cuts was a signal that we were looking at of like, what was if we extrapolate this, where does it go? So we looked at a lot of different languages and we decided we kind of liked Dart. And so we tried it. And then we tried filing some bugs and be like, hey, Dart team, like the first bug was like some weird thing about creating an empty string. And the Dart team replied like, oh no, here's this other API that we made for you that like, now you have a special API for making an empty string that's like a infinitesimally faster. We're like, oh, okay, this is a team that wants to collaborate, that wants to work together and build a thing with us. And that was what we were hungry for. Someone who wanted to build a thing.
Well, it also gets to the fact, I mean, there's so much luck in this, right? And there's so much lightning in the bottle that happened with, but there's technical factors and there's social factors. And like one huge happy accident of Flutter was that we were able to find this collaboration with Dart, right? And in contrast to like, again, I'm sure V8 was doing totally the right thing, but we filed a bug, one of many, 7 years ago, and it's still not fixed today, versus you look at these where we're filed against Dart and they were fixed 2 days later because like, we were able to build those relationships. They didn't have billions of users.
Ultimately, they cared about us, right? And if you look at where this, so we're talking about extrapolating, like where did this go from here? Like the influence that Flutter has had on the Dart language at this point is immense, right? Like it's sort of become a customized language for this UI framework, which is an amazing thing. Like you never get the chance to do that. Like But the seed of that was asking for the empty string to be like infinitesimally faster, because that was like the foot in the door. Like, okay, are we going to be friends? Like, is this going to work out? Like, you don't ask them to like remodel their house and
Sure.
like, get rid of null types, like rewrite all their entire ecosystem on the first day. You ask for the empty string to be a little faster, right?
And this led to, a year later having AOT support, and, a year later or 2 years later or whatever, having hot reload, all these like what are somewhat industry changing at some level advancements that just happened from being, able to build that collaboration.
What's been the same time WebAssembly is starting to be a thing? We have to look at the timeline. So there was a predecessor to WebAssembly called ASM.js, and there was a predecessor to ASM.js called Native Client. And definitely Native Client existed at this time, because the APIs that we were building on in Bravo were actually the APIs that were exposed to Native Client. But I don't know where in the like ASM.js WebAssembly thing. But you're totally right. Like, if you were to thinking about like how would I do Bravo today, you would totally do it in WebAssembly, right? You would do it in WebAssembly, and you would be backed by like the Web GPU API or something, right?
Yeah, and again, there's all sorts of like, I don't remember exactly the timeline, but Knackle was cool and all, but like I think was being sunset or merging into it, like becoming a different thing at this point in time. And I don't know where ASM.js was. And WebAssembly today, like we're talking a lot about WebAssembly right now, because WebAssembly is finally, and I don't mean that negatively, but like it's sort of like finally coming into its own this year and next year as it starts to grow like GC support and maybe better interop between having multiple WASM modules so they can like talk to each other and like.
Mojo's an X-Men villain. Hey, I also worked on the Mojo team. I don't have no knock on those folks. Was Dart used before Flutter? Yeah, Dart was definitely used before Flutter. So I think the original concept behind Dart is that it would be integrated into the browser sort of as a peer to JavaScript. So you can say script type equals Dart, and then program Dart and get faster, better scripting for the browser. And then it also, at this time, it had taken off, at least inside of Google, on the server to do basically really large, complicated websites that using the JavaScript at the time was just not up to the task of building such complicated web apps. Modern JavaScript probably better than that.
I think a lot of what happened was it ate Gwt. I don't know all the details. I wasn't paying super close attention, but like Gwt was hugely used. And
so Gwt, by the way, for people who don't know, is a Google Web Toolkit. You can go find it on the internet. It was a way of writing web pages in Java and then compiling them down to JavaScript.
And you have to remember there was a lot else going on in the industry, some of which involved Java at the time. And Dart ate Gwt, or big parts of some large Gwt customers, including ads, which I know we've talked about publicly many times. But like Google Ads, like all the money flows through Dart. And that has been, what kept this, what at the time, back when we adopted it, was this very bespoke language that was like used by ads and a few thousand people outside of Google. But
they were definitely interested in new customers, which is why they paid attention to us.
And it had such amazing fundamentals. And again, an amazing, like some really smart people had built a really nice language. I mean, I still to this day, I obviously do a lot of Dart. I'm very invested in Dart. But it's just this beautifully vanilla, language. It's
grown up since this time. Like at this time, it was really vanilla. Now it's got a little like it's got sprinkles and it's got a little more flavor to it.
Anyways, let's keep going. February 2015.
Yeah, so this is how long it took to move to Dart. Like it took basically 11 days. So like so like you should understand, like this is the ease with which it was able to work with the system, because when you have no customers, you can just change your language in a couple weeks, and there you go. Like no one's going to complain because ain't no one using this thing.
Well, you should. This is again all public. You can go look at Flutter Engine. The same thing you can do in Flutter, and you look at histories in time, and in GitHub it'll like go backwards. It's like starting from this commit, go backwards this number of commits. You have to go back 27,000 commits or 28,000 commits or something, depending on which repository. But you can just look and like, we were committing our tiny little, couple person team, 3-4 person team, 10 plus commits a day. It's like, oh sure, we'll change our language, and like you can look at lots of these and just see.
I don't remember whether I did the whole conversion to Dart or whether there was someone who helped me with it. But we had about 6 people working on it at the time. Not everyone was working on the Dart conversion. But yeah, like it was not like we had a very small system that we knew really, really well because we worked with it for many, many years prior. And with no customers, you can just make huge changes like this with very little effort.
And then the Stocks app, which does not exist still today. I think we've deleted it. But this was, so one of my passions, which was reinforced by this, is that I was constantly, from the very beginnings of this project, trying to get to carry. Getting to carry meant that the thing that we were building, I could carry in my pocket and use every day.
So the Stocks app was meant to be like the most basic like mobile app. So it would basically show you all these fake stocks with an infinite scrolling list because we were super focused on infinite scrolling lists, and it had a little drawer that would come out, and you could like click on a stock and it would give you little details about the stock. And it wasn't like real it wasn't like real stock data, it was like fake stock data. But it was a thing that you could carry around and show people, be like, hey, we built this thing, look at this infinite scrolling list. And it was so much better at infinite scrolling lists than well, at least the web, that we were proud of it.
I have shared the link of the slide per the question.
Yeah, the slides are just links to the GitHub. This is totally.
And again, this is all public. We literally pulled this all together yesterday evening, trolling through.
Was everyone working? No, not everyone was an ex-Chromium developer. Definitely not. So like so Ian Hickson, which is the third co-founder who's worked on this thing, was never worked on Chromium. He worked on the basically HTML5 specification. And then at some point we got folks who worked on Polymer, which was a separate team from Chromium. And then Google acquired a company called Portable, and some of the folks who worked on Portable came to work on our team. And then we hired some people. And
well, and actually, to be clear, it wasn't just the three of us who founded it. Like it was, it was sort of a roving band of minstrels, but they were about 6 of us, I think, initially, and 3 of us survived for several years. When the Dart transition happened, several team members left. It's an interesting thing, and Google has this whole, there's been all this study about like how teams form and learn, but like it took us a long time. We were doing this long period of like parallel play, which is like the thing you talk about with like kids learn how to parallel play, like play with their blocks next to each other before they learn to play with blocks together. But we were doing this long period of parallel play before we I think as we start to realize what we were building, we start to realize that what we were building there was this rationalization that had to happen of like, are we all building the same thing? Do we want to build the same thing? And it turned out no.
Yeah, like for example, some of the people who left really wanted to, it was really important to them that thing would reintegrate back into Chrome. That would become another rendering option alongside Blink. And we kept making choices that would make that less and less likely as the outcome, and more like it was just building a different thing. And so those folks, that wasn't what they wanted to do. And so some of them went back to work on Chrome.
Well, they went back to go and lead Blink and Chromium on to great justice. I mean, so much. Yes. And again, it wasn't just from this. There were many, other people noodling on these ideas at the time, but like so much of what we found in this was then like, this is why the web, or a, contributing reason. I mean, again, other people did the work, not us. We went off and did Flutter, but like, so much of the same problems that we were fighting have now been solved on the web or been improved on the web. But so,
by the way,
March.
Yeah, just to level set. So you saw how the framework looked at the time in JavaScript. In Dart, it looked exactly the same. It was the same sort of custom elements. It had CSS. It had templates. It had script. But then after we arrived in Dart, something interesting happened. So there's this person on the project.
This had already been going on to the side. There had been like this example, but yes, you tell the story. I don't need to.
Yeah, so one of the people working on the project was named Raf. And so Raf had been deeply involved in Polymer and had built, I don't know how many, like model view, observer, controller based toolkits in his career. And I don't know how or why, but somehow the concept of a reactive toolkit caught his attention. And he we had these sort of long like discussions over lunch where he was basically coming to terms emotionally with the idea that he wasn't going to build another model view observer framework, that his next framework that he wanted to build was going to be a reactive framework. And he built this in the examples directory. Because we had this layered system, we had this engine underneath, and we had the Sky framework that basically most of our stuff was built in. And he could just build a different framework, in the examples directory and experiment with it and figure out what could it be.
Which is so cool.
Oh, Naka was doing Pinnacle at the time, yes.
That was portable Knackle, as opposed to Knackle, which was tied to a specific x86 architecture or something, right?
Yeah, Pinnacle is a lot more like WebAssembly is, where you compile to this intermediate representation that can then be run on any CPU architecture.
Yeah. And again, I look back at that stuff and I see it as success, right? It took a long way to get there, but like the only way you learn this stuff is by failing. And
the key is to fail fast. Like the only way to succeed in these kind of things is just fail fast. Like, you're seeing like we're keeping the time in here. You see, time is ticking by, but not super fast. Like, look how much we're failing. Like, we totally failed to build a model view observer framework, right? And so then we're like, okay, that didn't work. Let's try something else. Maybe that will work.
Well, again, if you look back, like you click forward to the next page in GitHub and you've like moved a day. Like we were just cranking it out. I mean, we didn't have anything else to do. There was like 6 of us. We didn't have any meetings. There was like
we're just all writing code. Just
writing code.
I was getting this thing with Ian where like, whoever got in slightly early in the morning would then send the other one just constant streams of code reviews and take about as much time to review the code as it would take to write it. And so somebody would just get like denial of service with code reviews.
So effing was going on. This was March.
And just could go back to just the code snippet just to show this. So just to see what this looked like, right? It's familiar with what you see in Flutter today, but not the same, right? So you have my component extends component instead of widget. The render function is now called build. It returns a node, which is not really the same thing as a component, which is a little not sure what's going on there. Notice that render doesn't take an argument. Like we hadn't invented build context at this point, so we didn't know that we needed it. But we had container. Container was a thing that we had early on.
Yeah.
But container at this time was very powerful because it was actually backed by what you would think of as an HTML element. So container could do all the things that an HTML element could do because what it really ended up being was an HTML element in a DOM rendered by an entire rendering engine. It was Bootman! Bootman, welcome to the show.
I'm not at all surprised.
I had no idea. So you have Flutter fans of the world. You have Bootman to thank for the fact that Flutter is a reactive framework.
You have Bootman to thank for lots of things.
Bootman is an amazing person. You should look him up on Twitter and check out Replicache. Replicache is pretty cool.
Yes, congrats on the GA on Replicache. I saw that. That was this morning or yesterday morning. Yeah. I feel like I had something more to say, but I forgot. So. March.
Shake to reload. So shake to reload we've had for a while. So keep in mind we're still running this thing that is loading its content off a web server. And so what is the development workflow for this thing? So you type some code in your thing, and then you take your phone and you shake it.
Yep.
And then shaking it causes it to reload and re-hit the server and put the thing in. So it's like extremely primitive version of hot reload. There's no UI affordance for it because we wanted to give full UI control to the developer, but we thought the kinematic motion of the phone was a thing. Anyway, we had this for a while. I just put it in here because we broke shake to reload. And so this is a CO where we fixed shake to reload because it was critical to our development process.
It's also another failure along the way, but like, yeah, an amusing
shake to reload is nonsense. Like clearly the thing that we have now where when you like save, then it's like, oh, I should update your phone. It's a lot more sensible than like type some code, save, pick up your phone, shake it. Like it's nonsense, right? but the idea is there. Like the seed of what would become hot reload is here even now.
Because remember, you're still running Sky Shell, which is itself Chromium, a fork of Chromium. Like this is not even like a direct Android app. This is Chromium, loading your .sky file. March 2015, effing and getting to carry.
So Evan was like a great success. So it worked great. We loved it. So we built a ton of 3 apps using it.
I remember, so this, just like with Dart, I remember effing was another change management problem. This idea that like, the team had to like both technically understand React.
I don't know if that actually happened. I don't remember ever like losing grip of my phone and having it fly across the room.
But effing like just like Dart, we had to like the team both had to technically understand what we were changing to, but also had to like emotionally understand. I remember that being but yes, Replicache. You should check out Movement's thing. Replicache. There you go.
But this CL is critical, right? Because this CL, we like, we accepted Raf's thing. Raf was like, he built an examples directory as like non-threatening. Let's try it out. And here, this is the project saying, this is great, Raf. Good job. We love it. Let's take it out of the examples directory and put it in a directory called framework and be like, this is our framework. We love it.
Yeah. It moved from being the parallel play part to the being like everyone working on it. It was no longer Raf's thing. It was like the team's thing. You know, I mean, this became Flutter, right? So we published to the Play Store.
So one of the things we built here was the fitness app because Eric he was interested in fitness as it's one of his top 5 values is fitness. And so one of the things the fitness app wanted to do was he wanted to chart his weight every day. And so it needed a graph. And so in order to need a graph, we needed custom paint. So then we added custom paint. Like everything was built in that way where it was driven in the end from some user need. And then we would feel what it was like to satisfy that user need.
And then this is the first time we talked publicly and probably moved from 0 users to 10 users. I don't even know if you really could use the thing. I mean, like looking back, we had nothing at this point. I mean, nothing, but like it
was a toy, but we were playing with it, right? Like it was there to be played with, right?
But if you haven't, I mean, I don't need to self-promote my whatever, this is 7-year-old video, but like if you want to see what this was like, with Mojo and Shake to Reload and DOM-like things, this is me selling what would become Flutter, then called Sky, at the Dart conference in 2015 in the San Francisco office of Google.
But I just want to point out, notice that we've already embraced FN at this point. We've totally rewritten, like changed the framework. But here he's presenting, if you look at it, is clearly the old framework, right? Because we didn't want to disrupt this talk. We gave this talk from like a stable-ish build of this thing.
Huh, I had forgotten that. So here we go. And we said goodbye to the DOM, goodbye to the old framework. Oh no, this is not even just FN. This is we let go of the DOM and we moved to our own rendering layer.
So this was a huge, huge step. So prior to this point, we still had basically like a browser has this C++ rendering engine underneath that had like a DOM and a render tree and all this stuff. And here we lifted all that stuff into Dart underneath FN. And so the FN code basically stayed very similar, but container, instead of just being backed out by a DOM node, was now backed out by what was called a render node at this time. That was then a render tree that we had built inside of Dart. And so this is, I remember what happened is Ian wrote the spec for the render tree. And if you read the HTML5 spec, as we saw in the earlier episode, it's very procedural, right? It says, do this, then do that, then do that. And so Ian had the idea of writing very like precise imperative specs. And so I was pushing him on this, like, hey, if you're going to write your precise imperative spec, I've got a fully specified imperative like language for you to write your spec in called Dart. What if you wrote your spec in Dart? He's like, oh, okay, that's a good idea. And so he wrote his like spec basically in Dart and never ran it, as far as I know. And so then, like at some point, he was like, okay, I think I have something that works for a render tree. And so he took his spec that he'd written in Dart and I just put it in the compiler, and like it worked. Like I don't know, I've never seen someone write a like significant amount of code without a compiler.
Yeah, so
I will credit myself. I did make one improvement. In his layout function, he passed min and max height as 4 separate arguments. And I convinced him, like, can we make a struct for that called box constraints and then pass it as 1 argument? So I'm very proud of having very slightly improved over his API design. Ian, of course, is a master of API design.
So at this point, we're introducing a non-Chromium backing to this.
Right? And we have both, by the way. Like,
yeah, we made it switchable, like with a.
It was actually like both could run at the same time, like the same build of everything. You could either use the entire DOM, or there was some backdoor you could poke through, and you could like basically present a display list directly to the root.
And you also notice that all these things that you now think of as being in Dart were still in C++. Like the way that we added a point class was like we had, oh, maybe this one is. Oh, I see. We just have converters to get it in and out of point. But many of the classes were still the primitive classes that you think of today, like I think color and stuff was still backed by a C++ object at this point.
So this is FN2, right? Because we've now completely redone the guts of FN in order to get rid of the DOM and have it be built in a Dart render tree. And then we had to take all of our examples that we had written and port them to this new framework. So throughout this entire time, that spinning square that you saw at the very early in the project continued to work this entire time, just got refactored along with everything to keep working. And as we got more sophisticated apps, they also had to come along for the ride.
Yep.
Yeah, there's spinning square, and now it looks like this. Totally different, but still working.
Well, you see it's no longer in, it's now spinning square.dart. We dropped the .sky. We dropped the script tag wrappers, basically.
Because they serve no point. Like, what was the point of a script tag wrapper? You just write the code. Like,
well, we dropped CSS. Presumably, it's part of this as well. We had dropped the style parsing and stuff. Okay, now we're up to June.
So now we had this new thing. So okay, we should try it. So we built a lot more things. So we built like a bunch of material design things. We built a routing navigator routing framework. We there was one of our teammates was building a game inside of Flutter. And had to, I forget what his game engine was called, but it was like this space shooter thing where you could fly your spaceship around and all these other spaceships. Yeah. And he was stressing the framework in a very different way from the stocks app. And so we had to do things like we created an asset bundle. So you could put all the game assets together and he wouldn't have to download them from the server every time he launched his game. And this is sort of the birth of offline mode, or what we now think of as an app, like when it contains the stuff it needs to run.
So you can actually see, and the examples looked, so this is Sprite widget. So this is this individual used to work at Google and then left. And we deleted this code, but he kept it or resurrected it into this package. So you can still run this on modern Flutter. This is the fitness app.
Oh yeah, the fitness app had an animation of this person in it, built using the game framework. It was a really cool animation.
This is a weather demo, which was added at some point. This was Space Blast. So obviously they looked, if you go digging in the repository in this ancient time, they look different, but like they were there.
And then MindDigger is important. You want to click through MindDigger?
So MindDigger was a customer submission.
Yeah, this was someone who didn't work on our team, who didn't talk to us, built this app. It's basically Minesweeper from Windows, but with the names changed to protect the innocent. And then he basically submitted. He said, "Hey, here it is. I built this app," and it was cool. It's like someone who wasn't on our team had like built a thing, and they could do it without talking to us.
Like 300 lines of code. But this is when you start. It like starts to become real.
How do we decide to focus on mobile? This was baked in from the very beginning, because the underlying problem that we were trying to solve was that we had tried to bring the web to mobile, and we hadn't done it to our satisfaction. And so we thought, okay, how are we going to bring this aesthetic of the web to mobile about changing, like not being wedded to the technologies or to the compatibility with the web, but keeping the spirit animal of the web, if you will. And that was the underlying problem we were solving. So mobile was, in that sense, baked in from the beginning as the target.
And we talked about that. I mean, it was the same goals basically back in Bravo. Maybe I dropped that, or we dropped that in some edit in the slide, but we talked about the goals of Bravo. But I remember Chrome used to talk about slice: secure, linkable, indexable, composable, ephemeral. We obviously didn't keep all of those, but that was the kind of like, how do we keep the spirit animal, as you said, of the web?
But without getting focused on like, does it render spacejam.com?
Let's see, other things. We're a little behind in time, but that's okay. You know, we don't do a lot of 100th episodes.
I think we just keep going. What's next after scaling up?
Other things. Oh, I do want to mention, so asset bundle, we don't have to show it, but we added asset bundle. This is when we started to make it possible to be offline, be cached locally. And we also started iOS at this point.
Yeah, that was a big step for us. Like we didn't do this. One of our teammates did this. They made a thing like SkyShell that ran on iOS. Because obviously, if you're going to run on mobile, you got to run on the major mobile platforms, not just Android. We didn't do that at the very beginning because we had to focus, but we felt like we were getting somewhere, and so it made sense to scale up.
But so like once we added this ability, and again, everything still worked in both, but as we added Skyview, once we dropped WebView, we were dropping all the Chromium code. It was just all gone at that point.
We're asking somewhere around here, what point is... I really just want to build a really fast rendering engine. Yes, that's what I thought. Because like I'm not good at building end user things. Like I feel like I'm a like really at heart a person who empowers other people. And so I thought if I could just build a really, really fast rendering engine, somebody would do something cool with it.
And they did.
We were using material design as a reference point here because that was also like a challenge problem. Like there was a spec that contained a lot of really advanced, beautiful UI that was like other teams that had difficulty like making actually work. So we're like, okay, what if we just take this as a spec and go implement it? Because I'm not an artist, but the people who made material design, those are artists. And so we just implemented it pixel for pixel.
And again, if you look back through,
maybe Hal, welcome. Yes, thank you.
Inkwell and welcome, maybe Hal. We've got a few more. So,
this is a huge problem. So the stocks app, which we had this entire time, we've now loaded in an enormous amount of Dart code into. Like previously, when it started out, it was a very tiny amount of code running on mostly a C++ engine. But now it has an entire render tree written in Dart.
Yeah.
And so what would happen is you would launch the stocks app, and for the first few seconds of using it, everything was super janky. Like you would open the drawer and it would go. Yep. But if you played with the drawer play with the app for a few seconds, then everything was nice and butterly smooth. And so to demo it, whenever we would demo it with people, we would pull out our phone, launch the app, talk to them real quick while you're like messing with the phone down here while they can't see it, and then hand them the phone to let them play with it.
Yep. And this was, I remember on iOS before we added AOT, which took a while to get, iOS startup, I think was 12 seconds or something like that, or it got to that point.
Yeah, so you had to launch the iOS demo before you went into the meeting.
It was...
And so this is at this point, this is our biggest request for the Dart team. We're like, hey, Dart team, can you please build us an ahead of time compiler? Yep. Because in order to launch fast and get predictable performance, we need this. And they did.
They did.
It took them some time. Like it's building an ahead of time compiler is no easy task, but they delivered. And boy, did they deliver.
Yeah. Well, it continues to improve to this day. Like the ahead of time compiler, I remember the engineers talking like this is kind of hacky. Like we're just jitting the stuff and dumping it to disk kind of thing. More obviously a little more complicated than that. But like I'm watching them continue to improve the AOT compiler today as we continue to squeeze more performance out of these phones.
So this is another big problem we had. This was in FN2, there was a very serious fundamental bug with the system. And the bug was that configuration information, what you think of as a widget today, and state information, what you think of as a state object today, was the same physical Dart object. So when the object was inserted into the tree, you get a callback like a init state, like you get today, that would then initialize the stateful part of the object. And then if the parent was rebuilt, the object would get notified of its new configuration, and you had to basically copy that over into your state object. But there was this problem where this object existed and the developer had a pointer to it, which meant that the developer who didn't really quite understand how everything worked, one of our customers did this a lot, would include the same object in the tree in multiple places. And what would happen is they would fight with each other because they were trying to share state. And we couldn't just reject this out of hand and say, oh, you put it in two places, don't do that. That's an error. Because if you wanted to move something around in the tree, like you could either move it forward or backward in tree order. And so it was really non-obvious whether something was getting moved in the tree or getting multiply inserted. And it just like, the whole app would just like fall over and die with these state confusion errors. And so the solution is we separated widget and state into two separate objects. And so now, like it is today, what the widget is a factory for state. And if you put the widget in the tree in 6 different places, no problem, you'll just get 6 different state objects. And so this basically required rewriting the entire framework. So now this is FN3.
And this is example number, I don't know, 50,000 or whatever, of where you are not your customer. This is something that was very much reinforced for me in this. You are not your customer, and
Yeah, I never made this mistake. Like, obviously, you don't put the thing in the tree twice. Who would do that? That would break everything.
Well, you just know too much when you build a thing, and so like it's so important to. And we did this for all of our. We'd go sit next to them, or we'd go fly and sit next to them, and we'd watch them use it. And you can't type for them. You taught me this. You can't type for them. You have to watch them type it. You have to watch them type it wrong, and you take notes and you go back and fix it and put in the doc where they looked for it in the doc. It just you do that 1,000 times.
A tight iteration. Like I worked with this engineer, and like he would have a problem, and I would fix it. So the next day, it would come back to his desk, and that problem was fixed, and he can move forward, right? And so then he was willing to do this for days and days on end. And so, like, these are just, you can also just think of it as failing. Like FN2 just failed. It just didn't work. Yeah. If we tried to go to space with FN2, we would be forever writing articles explaining to people, please don't step like that. It's going to hurt, right? But we still at this time had the flexibility because we had a few customers. We had like on the order of like a dozen customers. And so this was a big ask. We went to the customer and said, sorry, customers, like I realize there are a dozen of you, but we're going to need to rewrite this framework. And we're going to help you. We're going to go into your code base when this is done. And yeah, they're fuzzers, exactly. And we're going to work with you. We're going to rewrite all of your code to this new framework. Today, this would be impossible, right? There's like basically an infinite number of Flutter customers. There's no way we could make such a fundamental change to the system. But we wouldn't have this many customers today if we hadn't fixed these basic issues.
You can't go to space without, and this is just one of these you harp on is that you just have to do it. And this is why like demos and customers are so important because they get you to these things. A failure mode I see so many teams fall into is they, build out all the things. They type out all the material widgets without actually getting a customer to do it. And so you end up either writing too much or writing not enough, or you have some like fundamental mistakes in the system.
It feels good to scale up, right? Scaling up feels great. Like, look at this beautiful like demo I can give you, a beautiful sample I can give you, all this work that I did, but it's wrong. Like you have to just do this least you can do to feel the next piece of pain, fix the pain, iterate and iterate and iterate, and then scale up. Thanks. I'm glad you appreciate it. We will someday cover Fuchsia again. Not today, though.
Yeah.
I realize it's a persistent question people ask, and we will definitely do it again.
So we only have a few more slides. I know we're over time, but our 100th episode, we're celebrating a little. I still cannot believe we've done this 100 times.
Go back to the early episodes. We failed at those too.
It looks like this is a quote from the commit.
Thanks. This is just the prototype of FN3. And if you go to the next slide, you can see. So this is in, if you look at this code.
Modern Flutter.
Yeah. This code will all look familiar, although all the names are weird. So that's how long it took. So then we finished the port. We converted everything. We deleted the old thing. And then at the same time, we named the project Flutter.
Yeah, I mean, there was a lot going on. The team was starting to scale. We had gotten a PM. We knew when we picked the name Sky that we'd never ship. I remember we did the trademark search, and I've said this in other stories before that like we failed to find a trademark that was useful, but like Google had a little bag of them of companies that they'd acquired, and we found one out of there that worked.
Trademark search is very difficult, by the way. Do not.
But it is
glad you like this framework. Yes, you are our oldest fan. We love you so much.
Even submitted to
our very first coding challenge. Hal submitted an amazing animation of basically the Hal 9000. Sorry, I don't want to make a gendered assumption.
But yeah, basically the same. Modular a few things. It was a little different. This was the T-shirts we had at the time.
I drew this logo with a mouse. We actually hired somebody to like actually make a logo and like pick some colors that were good, and we did a whole thing where we went through several just renaming to like get name once we like knew what things were and what they were called. But yeah, FN3. You think of it as Flutter. In my heart, I know it's FN3.
And again, everything we saw today, I mean, the deck I pointed to is all public. All these commits are all public. You can go read them through. They're all on GitHub.
The one very important piece of feedback that our boss gave us is that this logo is not good, and we should get a professional logo, which I think was a good call.
Yep. Well, that was all the slides I got.
Yeah, thanks everyone for coming out to the 100th episode. I really appreciate it. Hope you enjoyed the story. It was really fun to tell the story. It was really fun to live the story. And yeah, just keep failing, but fail fast and like get better each time. It's the way to live your life. It's how I live my life.
And we'll see you next week.
See you next week.
Good night, all.